At result Gokul. I'm working as an assistant professor in the Department of Master of Business Administration. It's to Kumar Technology. In this video, we are going to see the part 4 of the descriptive analytics and visualization. The subject code is MB25202, Regulations 2025. Today, we will explore the core statistical measures that describe data sets, measures of central tendency, and dispersion. In this session, we will cover measures of central tendency, mean, median, mode, then measures of dispersion, range, Quartile deviation, mean deviation, standard deviation, then measurement of shape, skewness, and kurtosis. Let's begin with the central tendency. A measure of central tendency is typical value around which other figures congregate. Congregate represents the central or typical value of a data sets. The three main measures are mean, median, or mean, which means the arithmetic average, median, the value, then third, or the most frequent value. Each tells us something different about the data. Then mean, the mean arithmetic mean is the sum of all observation divided by the number of observation. The formula is mean equal to the sum of all values divided by number of values. Example for value 10, 20, 30 mean. This means you have to add all the values divided by there are three observations divided by 2 by 3, so the mean value is 20. The mean is sensitive to extreme values. A few very high or low numbers scans. Then positional average. Positional average depends on the position of items rather than their exact values. Median and mode are positional average. They are determined by where values are fall the ordered data sets, not by the magnitude of every value. The positional average has been divided into median or quartile describes the median. The median is the middle value when data is arranged from least to greatest. Half the data are below the median or above. Finding the median, where we can find the median by the odd number of observation, which means the middle value. The even number of observation means the mean of the two middle values. Examples data sets 5, 8, 12, 15, 20, where the middle value median is 12. In case of even means 5, 8, 1, 15, median is median. You have to take two middle values, 8 plus 12 divided by 2. So the median is 10. The median is not affected by extreme values. It's a robust measure. Then mode. The mode is the value that occurs most frequently in a data set. Examples data sets 2, 3, 3, 5, 7, 7, 7, 9, where the frequently appear number is 7. The 7 is appeared more than 3. So the mode is 7. Data set 1, 2, 3, 4, 5, no, no. All values occur only once in a tree. So there is no mode in this value. Then data set 1, 1, 2, 2, 3. There are two maps, 1 and 2, which is again it's a binary. The more is useful for categorical data and identify most common then measures of dispersion, while central tendency tells us where center is. Dispersion tells us how spread out the data is. Two data sets can have the same mean, but very different spreads. Measures of dispersion include range, quartile deviation, mean deviation, then standard deviation. First, we will see the range. Range is the difference between the greatest and smallest values. So the range formula is L minus S, which means larger value, and S means smaller value. Coefficient of range means L minus S divided by L plus S. Then quartile deviation is Q3 minus Q1 divided by 2. In case of coefficient of quartile deviation means Q3 minus Q1 divided by Q3 plus Q, where the quartile deviation Q1, Q2, Q3, Q4 is divided depends upon the percentage and different percentage for the each point. One means 25, Q50, Q3 75, Q100. The mean deviation. Mean deviation is the average of observed difference between each value, the mean of the data set. Formula mean deviation equal to sum of x minus mean divided by n, which means number of observations. We use absolute values to avoid positive and negative difference cancelling out. Mean deviation is a simple measure of average distance from the center. Then standard deviation. The standard deviation is the square root of the variance. It's the commonly used measure of dispersion. For a population, standard deviation formula is 2. And for the sample, standard deviation formula is 2. You can see that on the slide. The standard deviation tells us on average how far values are from the mean. It's in the same unit as the original data made interpretable. Then we can see the variance. More commonly used measure of dispersion is the variance, whose computation depends on more data. There are larger the variance, the more the data are spread out from the mean, and the more variability one can expect in the observation. The formula is been given, where x1 is the value of I item, n is the number of items in the population, and u is the population mean. Essentially, the variance is the average of the squared deviation, the observation from the mean. Coefficient of variance means it provides a relative measure of the dispersion in data relative to the mean and is defined as coefficient of variance equal to standard deviation divided by mean. The reciprocal of the coefficient of variation called return force is often used because it is easier to interpret. And measurement of shape, which includes Skewness and Kurtosis, beyond center and spread We also care about the shape of the distribution, skewness, which is asymmetry, and kurtosis, which is weakness or flatness. These tells us more about the pattern of data. Skewness describes the lack of symmetry in data. Positive skew, which means right side skew. The tail extend to the right. Most values are concentrated on the left, with a few high values stretching the tail. This means mean greater than median, greater than more. Tails negatively skewed, which is left skewed. The tail extends to the left. Most values are on the right, with a few low values. Mean less than median, less than more. Symmetry. Data is evenly distributed around the center. Mean equal to median equal to more. Understanding schemas helps in choosing appropriate statistical methods. Then coefficient of skewness. The coefficient of skewness measures the degree of asymmetry of observation around the mean. The coefficient of skewness is computed as per the given formula. If CS is positive, means the distribution of value is positively skewed. If negative, it is negatively skewed. The closer CS is to zero, the less the degree of skewness. The coefficient of skewness greater than 1 or less than 1 suggests a high degree of skewness. A value between zero point 0.5 and 1 or between minus zero point 0.5 and minus 1 represents moderate skewness. Coefficient between zero point 0.5 and minus zero point 0.5 relate to symmetry. Measures of skewness. There are two measures called Pearson coefficient of skewness, then Pauli coefficient of skewness. I have mentioned the formula also in the slide. Then kurtosis. It refers to the peakedness that is high or narrow or flatness which includes short or flat top of a histogram. Coefficient of kurtosis. The coefficient of kurtosis measures the degree of kurtosis of the population and can be computed using Excel functions with data range. The coefficient of kurtosis is computed as per the given formula. The distributions with values of CK less than 3 are more flat with a wide degree of dispersion. Those with value of CK greater than 3 are more weak with less dispersion. That concludes part 4 of Unit 3. We have covered measures of central tendency, dispersion, and shape. In part 5, we will explore sampling, estimation, and probability. The bridge between we bridge from descriptive to differential statistics. If you found this video helpful, please like, share, and subscribe. Leave your questions in the comments. Thank you for learning with me. See you in the next part of this event. Thank you.